This is my Chapter 15 reassessment. It says a thin plastic disc of radius 0.6 meters is uniformly charged with -3 × 10 to the -7 coulombs and attached to a thin glass rod of length 2.4 meters that is uniformly charged with 5 × 10 to the -8 coulombs. The center of the rod and the center of the disc are both at the origin. The rod lies along the x-axis and the disc lies in the YZ plane. So what is the electric field at that location? So this is a picture of what it looks like, the disc and the rod. You have to use the superposition principle and add the electric field of the disc plus the electric field of the rod. So first we have to find the electric field of the disc by using this equation. We use this equation because this location is much smaller than the actual that location here is smaller than the radius here. So by using this equation, we just plug in the charge over the area, which is pi r squared, over 2 epsilon naught. And we get this, which is negative because there's a negative charge. So that means it's in the negative x direction as a vector. Now we can find the electric field due to the rod by using this equation. And we use this equation because this location, which we know is for the rod because it's in the YZ plane, so this is the Y, there's nothing in the Z direction for the electric field, so this is much smaller than the length of the rod. So we use this equation and just plug in the numbers that were given and we get this. So that's in the Y direction when we write it as a vector. And by adding those quantities together, the electric field of the disc plus the electric field of the rod, we get that you just have basically the quantities that we received by themselves. They don't actually add together because one is in the x direction, one is in the y direction. But we do have them together as -1.49 × 10 to the 4th in the x direction, 3.75 × 10 to the 4th in the y direction, and there's nothing in the z direction, and that's in newtons per coulomb. I showed up here that they cancel out, and you're left with newtons per coulomb. And that's the electric field overall as a vector for this entire thing.